Natasha Anderson with the Center of Expertise for School IPM. I have the pleasure of being your moderator for today's program. I would first like to thank you all for joining us today. Today's webinar will discuss how to look for and manage mosquitoes on school grounds and how to be proactive in your approach to mosquito management. Integrated mosquito management is all about preventing the transmission of potentially dangerous mosquito-borne illnesses and preparing your school. It is important to know exactly what you should be doing if, when, and where mosquitoes become a threat. You've all seen the headlines and heard the threat of the Zika virus, the latest in mosquito-borne diseases to affect the U.S. and our southern neighboring countries. Mosquito-borne diseases such as Zika, dengue, and West Nile raise significant public health concerns. EPA advocates mosquito control that is based on the scientific and practical principles of integrated pest management. But what is IPM? IPM is a comprehensive approach to dealing with pests using strategies that are smart, effective, economically sound, and ecologically sustainable. We recommend putting into practice a proactive IPM approach to mosquito management in schools and to have a plan ready to activate if and when mosquitoes pose a threat in your district. IPM for mosquitoes involves the identification of mosquito species and surveillance monitoring of their populations at all life stages. When populations of mosquitoes reach action levels, appropriate health officials should take steps to lower those populations using a variety of tactics that may include draining standing water to reduce populations of immature mosquitoes, releasing fish or other organisms that eat immature mosquitoes, screening adults from reaching students, and treating immature mosquitoes with biologically based pesticides, called biopesticides. These actions can also involve conventional pesticide treatment as appropriate. When mosquito populations need to be managed, professionals should use IPM tactics that are effective, minimize harm to the public and the environment, and are sustainable. Protecting the public from insect-borne diseases is a community effort. Schools are a cornerstone of all communities, and the protection of our students, faculty, and staff from mosquito-borne illnesses is what brings us together today. I have the pleasure of introducing today's presenters. Each brings their expertise and unique perspective on Zika and other mosquito threats and the management of mosquitoes. Our first presenter will be Commander Joseph Lako. Commander Lako is an active duty service member of the U.S. Public Health Service stationed at the Center for Disease Control and Prevention in Atlanta. He's an environmental health scientist in the National Center for Environmental Health, where his work focuses on vector control, emergency and outbreak response, food safety, drinking water, wastewater, and hazardous materials. Next will be Dr. Mike Merchant. Since 1989, Mike has served as the Urban Entomology Specialist at the Texas A&M Research and Extension Center in Dallas. He is a leader in promoting IPM programs for Texas public schools and works with the U.S. Department of Housing and Urban Development to encourage IPM use in public housing in his state. Wrapping up the program will be Dan Lisinko. Dan is the Grounds and Maintenance Manager for the Manatee County School District in Florida. He has been a licensed commercial pest control operator for over 30 years. He holds certifications in aerial mosquito control, National Playground Safety Inspection, and heads the Wild Bird Program for his district. He will provide his boots-on-the-ground perspective of mosquito problems and solutions from his Florida school district. So without further ado, Commander Lako, please take it away.
Hi, everybody. As mentioned, my name is Joe Lako. I work in Atlanta at the Centers for Disease Control, and I'm going to get this conversation started with a little bit of background information about Zika and mosquitoes, and the other presenters will discuss on how we control and mitigate those mosquitoes as they relate to Zika. So on slide 7, the first definition, I'm going to use a lot of terms and jargon, but understanding what is a vector. This is a transmitter of disease that can cause illness and sickness in people, and they are capable of carrying one pathogen from one host to another. And that host may be a person. That transmitter may be a mosquito. So the mosquitoes that we are most concerned with for Zika are of the Aedes variety. And in particular, there's two that are of significant importance, Aedes aegypti and Aedes albopictus. And Aedes aegypti, we have a picture of it there on slide 8. You can see has the characteristic white bands on the legs and also has some characteristic lines on the back of the thorax. You can see here. Aedes aegypti, in addition to Zika, is capable of carrying yellow fever, dengue, and chikungunya, and has acquired the nickname of yellow fever mosquito during the building of the Panama Canal, was responsible for many yellow fever illness and outbreak. These are daytime biters. They are very closely associated with the activity of humans. They prefer to feed almost exclusively on people and prefer to breed almost exclusively in artificial man-made containers. Understanding some of their behavior and biology, they lay their eggs in single, one at a time, in multiple locations. Our next one, very closely related to Aedes aegypti, is Aedes albopictus. And this one is commonly referred to as the Asian tiger mosquito. Has very similar biology and behavior as Aedes aegypti, capable of transmitting dengue, chikungunya, yellow fever, as well as Zika. Also, daytime biters, these guys are notoriously aggressive. They will feed on just about anything that moves, not just people, but they'll actively feed on other mammals and birds as well. They prefer to lay their eggs singly in artificial containers, but will also lay their eggs in more natural settings like a tree hole that has been filled with some rainwater. They have a characteristic marking to distinguish them from the Aedes aegypti on the back of the thorax with that single white line. Notice they also have the white bands on the legs, but that single white line going down the dorsal side of the thorax is the giveaway. And usually that white line is very bright and will stick out quite distinctly, even though these guys are pretty tiny. So where do we find these mosquitoes capable of carrying Zika? This map was put out by CDC earlier this year. This estimates the range of both Aedes aegypti and Aedes albopictus. You'll notice that they overlap and are very similar, but the albopictus, the Asian tiger mosquito, has a little bit northern range. Their eggs are capable of overwintering a little bit better than the Aedes aegypti, where you'll find those mostly in the southeastern states and the southern bordering states and the Gulf states along the Gulf of Mexico. You'll also notice there, I don't know if we have any callers from Puerto Rico, but highlighted on the Aedes aegypti side on the left, you'll see the presence of Aedes aegypti in Puerto Rico, but we don't have any Asian tiger mosquitoes in Puerto Rico. So we have exclusively Aedes aegypti present in Puerto Rico. This range is just an estimate. It's a display of where we have actually physically captured, found, and identified these mosquitoes at its northernmost range, and the assumption has been made that if it's present at a particular latitude, it could also be found and capable of surviving south of that. It's important when you're thinking about controlling mosquitoes, controlling Zika, addressing a potential outbreak, is to take a look at the entire life cycle of the mosquito. Mosquitoes are insects that have 4 life stages: egg, larva, pupa, and adult. Aedes aegypti in particular can live inside your house and live its entire life cycle inside your house, laying eggs in artificial containers that may have water like a flower pot. You could see that the eggs, larvae, and pupa require water. Eggs are laid at the surface of the water. The larvae will actually live and eat and swim in the water, and the pupa, which is the last stage before it emerges as an adult, also happens in the water. This is really important to understand the importance of water in the mosquito life cycle because it plays a critical role in how we help control the populations of mosquitoes. Entire life cycle from egg to emerging adult is about 8 to 10 days. I'm going to have a lot of pictures on some of the following slides to show you some of the places that these mosquitoes like to live. These are examples of artificial man-made containers that the Aedes species particularly like. This is where they will lay their eggs. Right here where I have the green arrow, you see a used discarded tire. Infamous for Aedes breeding site are used discarded tires. It's a particular problem in some other developing countries throughout the Caribbean where they have a great dependency on used tires that come from America. But you can see other artificial containers, flower pots, watering cans, buckets. Here where we have a rooftop that is filled with leaf debris and leaf litter, this may provide inadequate flow of the rainwater down the gutter and provide puddles, pools of water that are going to be great for Aedes to lay their eggs. Aedes also like smaller volumes of water that's a little bit cleaner rather than dirty and murky. Here's a picture of what the eggs look like, and you can see that they are very small. They're smaller than the tip of the lead of a pencil, and they lay their eggs on the side of the containers, and they're sticky. They're going to sit there. They're capable of desiccation and being dried out. Even when the water evaporates out and the water level goes down, the next time it rains and the water level rises in that container, that's what's going to trigger the eggs to be hatched. These are what the larvae look like. They're called wigglers, and you could see right here and again right here. Those are little tubes that extend out from their body, and that is actually a breathing apparatus. So it's important and a critical aspect of the mosquito life cycle that they actually require air. So this is how they're going to get their oxygen from the surface of the water. Here's another picture. If you go back to the previous slide, these are very beautiful pictures. They look nice and clean and crisp and clear, but that's not how it's going to be in the real world. You can see some pictures here in this bucket where you have larvae with their own waste in it and the food, and it's going to be a little bit yuckier in there. This picture here I put in there on purpose. It's not an artificial container. That is more of a flooded natural setting, maybe a roadside ditch or a flooded field or a flooded area of a playground. This is where you will not see Aedes lay their eggs. But other mosquitoes will lay their eggs in standing water like this. There's over 6,500 species of mosquitoes, not all of which feed on people, not all of which are capable of carrying diseases, many of which are going to lay their eggs in flooded standing water, like the picture on the right, are going to be nuisance mosquitoes, which can be quite numerous and cause lots of problems as well. Here's the pupa, the last stage before it emerges as an adult. And you can see again, there's a little tube that reaches up to the surface of the water of how the developing mosquito is going to get air from the surface. These are some pictures of emerging adults coming out of the water. Remember that the Aedes species has the characteristic white stripes on the legs. So the mosquito on the left, you could see the white stripes on the legs. We know that's an Aedes mosquito. The species on the right doesn't have those white stripes, so this is not an Aedes mosquito. Very well may be a different species that can carry other diseases besides Zika, dengue, and chikungunya. This is a picture on somebody's finger. So this is actually blown up image just to give you a little bit of a scale of how big these guys are. Remember some of the characteristic markings that we looked for were the white stripes on the legs, and there's that really bright white band that you can see on the thorax on the backside of the mosquito. This is, with that white band, an Asian tiger mosquito, Aedes albopictus. This photo was captured here in Georgia in Swanee by a coworker of mine, Brian Hubbard, and I begged him to let me use this picture because it's a really good picture of a mosquito in a natural setting. We know this is a female mosquito. Only the female mosquitoes will require a blood meal to provide nutrients before they could lay their eggs. Male mosquitoes are going to be a little bit smaller and have really large, fluffy antennae on them. They do not feed on people. So if you're going to be bit by a mosquito, you could assure that it's going to be a female acquiring a blood meal. Male mosquitoes feed on nectar and liquid that they find in flowers, much like bees and hummingbirds. So Zika. As mentioned earlier in the opening, it's been in the news now for quite a while. We first saw Zika show up in the Western Hemisphere in Brazil about a year ago. It's a disease that is spread primarily through the bite of an infected Aedes mosquito. And the most important word of that statement is infected Aedes mosquito. Aedes mosquitoes themselves don't carry Zika. They have to acquire Zika from an infected person, and then while they have acquired that Zika, then bite another person, a secondary host, and that's how the virus is passed on. But Zika virus in general have very mild symptoms, and you'll see all kinds of different numbers. In general, 4 out of 5 people, about 80%, will not exhibit any kind of symptoms at all and won't even realize that they're carrying the Zika virus. Even though they are asymptomatic, they are still considered infectious for a period that they have high enough viral loads in their system to infect a non-infected Aedes mosquito. So what are some of the symptoms? I'm going to get into that in a few other slides here, but this is another general slide on number 20 about how it's spread. We already mentioned mosquito bite from our Aedes species. But it also could be spread from a pregnant woman to her fetus, having sex with another infected person. It can be spread by both male to female, female to male, as well as male to male. We're currently screening the U.S. blood supply for donations because of the possibility of Zika being spread through organ, blood, and tissue transplants. Where do we find Zika right now? This date is on this map on slide number 21, you can see is from August 22nd. And I have a couple other slides that are dated a couple weeks old, and I didn't update them on purpose. But you can see that Zika, which originates in the Ugandan Zika forest in Africa, but this is the largest Zika outbreak in humans in history, originated in South America about a year ago, and it's quickly spread through the bite of Aedes mosquitoes throughout most of South America, all of Central America and Mexico, as well as the Caribbean. You can see on this picture on slide 21 that the United States is not colored in purple there. We do have local mosquito-borne Zika infections in Florida. This is another slide that has a date of August 24th. You can see that Zika can be found. Zika infections have been found in all of the U.S. states besides Alaska. Because as of today, on September 20th, there has been travel-associated Zika cases found even in Wyoming now. So this map includes all of the 48 states as well as Washington, D.C. But it represents mostly people that have acquired Zika while traveling abroad to the Caribbean, Mexico, South America, and then came back with the infection in their system. There's only been a handful of Zika cases that have been transmitted in the continental United States through the bite of a mosquito, and they have been in Florida. This map here is from just 3 weeks ago on August 31st, also has been updated. This shows the active cases from the Miami area where people acquired Zika from the bite of infected mosquitoes. The first neighborhood on the left there, it's the map on the right that's shaped like a rectangle. That has since been cleared of Zika in the sense that there are not any active cases of people infected with Zika that can transmit to mosquitoes. However, in the Miami Beach area, that range of the infected cases has actually expanded. I think I read the Florida Health Department expanded it from 1.5 miles to about 4.5 miles, square miles just this week. So control efforts are ongoing in those areas. So here in the U.S., as of August 31st, you can see all the travel-associated cases, and this is just a handful of the states. I didn't list them all. I listed some that you could find along the Gulf Coast and some that have some large urban centers with large populations of people that also have historical populations of Aedes aegypti and or Aedes albopictus. And you can see that the numbers are largest in Florida. Texas and California, those have an awful lot of people in it, people that travel to and from the United States. But all of the local cases, locally meaning acquired through the bite of a mosquito, have been in Florida. As of today, we had numbers that are represented of 43 cases. The 43 cases that you'll see on display on the CDC website are those that have been reported by the health department as positive laboratory confirmed cases into our tracking system called ArborNet. The state health department may have even higher numbers than that haven't been entered into ArborNet. But I left this old number here from the 31st to show that this is a moving target that is continually being updated as this disease progresses and as we continue to fight and prevent further infections. But you can see here some U.S. territories, particularly Puerto Rico, U.S. Virgin Islands, American Samoa. There are some caseloads as well. And just the last 3 weeks, so as of today, there's over 17,000 cases from mosquito bites in Puerto Rico. So this, again, is ongoing and quite dynamic. All right, what are some of the symptoms if someone has a Zika infection? They're going to be mild. You may have a low-grade fever with rash on your body, joint pain, conjunctivitis, red eyes. That's one of the telltale signs of the Zika infection is the bloodshot eyes. You're also going to have some mild flu-like symptoms like muscle pain and headache. These mimic a lot of other vector-borne diseases, other mosquito-borne diseases, particularly dengue and chikungunya. The media has focused primarily on Zika infections in pregnant women, and this is the biggest concern for CDC because of the potential birth defects that could be associated with the fetus. So the Zika virus can be spread from mother to child through the placenta and cause symptoms called microcephaly. Microcephaly is the lesser development of the human skull, and the virus actually also attacks the brain tissue, and the brain doesn't grow to fit the now smaller skull. So you have a smaller brain inside a smaller skull, which has serious ramifications for the development of the child. Other ramifications of Zika during pregnancy are miscarriage, stillbirths, eye defects in children, as well as hearing defects and developmental and physical growth impairment. There are no reports, it's important to note, of Zika being passed through breast milk, and no child has been infected with Zika through breastfeeding. Another medical concern, particularly in adults and young people, is Guillain-Barré syndrome. This is where the virus would attack brain tissue, particularly the neurons and the myelin sheets in the neurons that will cause some paralysis and muscle weakness. Most of the time, this is going to be self-limiting, and people do get better from Guillain-Barré, but sometimes it can be quite severe with long-lasting impacts. So how do you get diagnosed with Zika? And all the numbers that CDC will share with you and that you'll see on our website, those are laboratory-confirmed official diagnosis. It can be done with a blood test or a urine test through your doctor. There's no vaccine, there's no medicine, there's no cure for Zika. Really, you have to do what you do, for the most part, for the flu. You have to treat the symptoms. Lots of fluids, lots of rest, controlling fever with acetaminophen and other fever reducers, and also for the aches and pains. So if you have Zika, like you said, most of the time you're not going to have any symptoms, but you could still infect a mosquito that can infect somebody else. So it's very critical if you do have, the flu-like symptoms, if you've been to an area that's impacted by Zika and you've been bitten by mosquitoes, to protect yourself from mosquito bites. That way you can't infect a mosquito, and that mosquito can't fly down the street and bite another person and infect them, and maybe that person doesn't even know that they're 6 weeks pregnant. Before I get into some of the tools and resources, going back to the mosquito biology, the Aedes has a very short flight range, which is another component for understanding its life cycle and behavior that's used in control. They only can fly about 200 to 250 meters within their lifespan. They keep it pretty close to where they are hatched from, where their eggs are laid. So we have lots of information available at CDC and as well as other places on various government websites. So I'm going to highlight a few of them here to let you know about the different tools. When you go to CDC's website, you'll see a big picture of a silhouette of a mosquito to take you to the Zika homepage. And on there, we actually have a set of guidance documents, particularly for school administrators in the U.S. And if you download the presentations, I've included all of the links for those. But there is one for guidance for schools. CDC worked in partnership with the Readiness and Emergency Management for Schools group. They have a technical assistance center, and we were able to put together another presentation in the form of a document on helping schools prepare for a Zika response. And I'm going to go through a few highlights of that document and that presentation because they're particularly focused towards school administrators. So planning for a Zika virus response. If someone at your school has a Zika infection because they traveled out of the country or even got bit by infected mosquitoes. So some of the roles and responsibilities as a school administrator, a school nurse, a school official is to share information. Share some of the tools and resources that we have with your staff, with your healthcare nurses at the schools, with parents and students. Listen to your local health officials and implement the recommendations and guidance that they put in place and continue to work with them as we try to prevent further infection. Public health authorities, and these are the folks, your state and local health officials that are going to be on the front lines of the fight against Zika. You have to first identify your risk for Zika exposure. So do you live in an area where the Aedes mosquitoes are present? And then advising your communities and your schools on how to reduce risk of exposure to those mosquitoes. And we'll talk quite a bit about some of that today. This is one where is one of the easiest ways to prevent mosquito bites is the use of repellents. CDC recommends using EPA-registered repellents that contain DEET, picaridin, oil, lemon, eucalyptus, and follow the label instructions. Follow the instructions for use on children. It's not recommended that you use repellents on children under 2 months of age. And for other kids, it's a good idea if it's a spray or lotion to put it on your hands first, an adult's hands first, and then apply it to a child's skin. But most important, follow the label instructions that have been cleared for safety by the registration through the EPA. Another way to prevent mosquito bites is to cover up. Wear long sleeves. Wear long pants. That's not so fun to do when the weather's hot, and it's still hot in a lot of areas where we have these mosquitoes this time of year. But also wear socks. The Aedes mosquitoes, they prefer to have a flight range and a lifestyle that's pretty close to the ground. You're more likely to get bit on your ankles and legs than you are your neck or your head. So socks and spraying repellents and putting repellents on your socks is a great way to keep those mosquitoes at bay that are flying close to the ground. Here in the U.S., most schools, a lot of people that live in homes and apartments, we use air conditioning. We keep our windows and doors shut. It's a great way to keep mosquitoes out of your house. But we're also accustomed to using window screens and doors. I have a screen door on the back of my house. It's there to let the air flow, but it also keeps the vectors out of my house. You can treat your clothes and treat some of your gear, particularly if you're an outdoors type person, with some products that are used to get embedded into the clothes, like permethrin. Permethrin is not just a repellent, but it's also a pesticide that will kill mosquitoes. And the neat thing about pre-treating some of your gear is these are designed to last a long time, as well as repeated washings through your washing machine. Bed nets are important, I would say, for children that are taking naps. If you're in heavily mosquito-infested areas, because remember, these are daytime biters, and they're going to be most active at or during the day as opposed to night. All right, so if you have a case of a child coming to your school and they have Zika, the most important thing to do is to prevent that child from getting bit by a mosquito. Make sure that they are taking the steps as mentioned in the previous slide on how they can't infect another Aedes mosquito. Make sure that you disseminate accurate information. Try to dispel myths and rumors. Prevent stigmatization of students that do carry Zika. And this can be done primarily through maintaining medical privacy and confidentiality, as you do with all other medical issues at the schools. Provide appropriate medical management for students that are symptomatic, but isolation and quarantine is not recommended or really necessary for someone carrying the Zika virus. So what if you live in an area where you have local mosquito transmission of Zika? Your state and local health officials, your county, city health officials are going to be working closely with schools. Anytime that children are involved in a public health issue, that is put at the forefront and usually made quite a priority. So listen to the guidance and recommendations, just like we talked a little bit earlier. There are some guidelines and tools available specific for schools by and for your local health officials, and I'll show you some of those here shortly. But it's not necessary to cancel outdoor activities or suspend classes or cancel school. Talking to children about Zika, they may have a lot of questions. They may have heard a lot of rumors and got a lot of misinformation. So start the conversation by asking them what their understanding of Zika is. And this is going to vary, the level of this conversation is going to vary greatly from K through 12. But explain what you know about Zika honestly and simply, and make sure that any correct information that you're getting from the students is corrected with proper information. And explain what they could do to help prevent the spread of Zika, prevent mosquito bites, wear repellents, use screen doors and windows, use air conditioning. Now this slide here on number 39 is very busy, but this one has a lot of links on it for resources, particularly for children, for talking and communicating with children. The very first link there has a children's activity book that you can download. So there's lots of ways to communicate to children about Zika and about mosquitoes in general. NIOSH is the National Institute for Occupational Safety and Health. They are actually part of CDC. They partnered with OSHA that provides occupational and safety guidance for America's workforce, and they put out a guidance document for protecting workers from occupational exposure to Zika and mosquitoes. I have the link there for you with a picture of what the front page of that document looks like. Here's the front of the Zika virus page on CDC's website. There's that silhouette of the mosquito with the earth in the background, and you could see the highlighted yellow areas of the earth of the U.S. and most of Central and South America. That's more of an accurate picture of where we see active mosquito transmission of Zika, even though it's contained to a very, very small area in the United States, just in the coastal area of Miami, Florida. I really encourage you to visit our website at cdc.gov and click on the Zika homepage. There are, if you spend some time there, a lot of tools and a lot of resources that are available for all different types of groups, different mechanisms and different applications of how to communicate with different people. Some are infographics, some are posters, some are available for print, some are videos. These are some of the specific groups that are actually highlighted. We have some for parents, which is applicable for you. The health departments, having a good understanding of what health departments do will help a school administrator, a district administrator understand better when it's time to communicate and work with health officials concerning Zika. But there's also a particular link just for the school resources as well, and has information for you and for parents and for students. I know I rushed through a lot of that, but I want to be respectful of everybody's time. We got a little bit of a late start. I think maybe we're going to be holding our questions for the end.
Thank you, Commander Lako, for updating us on the Zika virus and all that the CDC is doing to guide the response effort here in the United States. Speaking next will be Dr. Mike Merchant on a number of controls and mitigation practices that can reduce the number of mosquitoes in your schoolyards. Dr. Merchant, go for it.
Hello, thank you, Shonda and Marcia. So my presentation is going to focus in on mosquito management. I'm from Texas, and everyone in Texas wants to know what they can do to solve a problem. And that's what we're going to focus on today is the different approaches to mosquito management, especially as it pertains to school campuses. And this is just a reminder of some of the species. I know for some of you who are not really mosquito or public health people, seeing all these different scientific names can be dizzying. But to try to simplify the concept of mosquito control, when you live in your communities and you have spring rains that bring mosquitoes, that is a certain type or group of mosquitoes. Those are generally floodwater species of mosquitoes. And from public health perspective, we're not too worried about those. Yes, they're a nuisance. Yes, they can transmit diseases to pets like dog heartworm, but floodwater mosquitoes are not West Nile virus carriers, nor are they Zika or dengue fever carriers. So we're going to focus today mainly on the standing water species, as Dr. Lako had talked about earlier. But this picture also shows an example of what I mean by standing water. Water that's usually in a small container, doesn't move around a lot, typically doesn't have fish or anything in there that could eat the mosquitoes. It's very well protected. It has organic material with bacteria that can feed the mosquitoes. And the Aedes mosquitoes and the Culex mosquitoes are both of this type. They breed in this type of standing water. Again, just some of our important species here. West Nile virus, for most of us, is still going to be the most important mosquito-borne disease in anywhere, in school districts all over the country. And West Nile virus is thought to be carried by a mosquito with a genus name Culex. There's 3 different species. If you're in the north, you're going to be dealing with Culex pipiens. In the southeast, you're going to be dealing with Culex quinquefasciatus. And in the western part of the U.S., you're going to be dealing with Culex tarsalis. They do have some slightly different behaviors and biologies, but we're actually focusing today more on the Zika vectors, which include, as Dr. Lako said, Aedes aegypti and albopictus. Now, I don't know what your school campus looks like, but this is a school campus I visited not too long ago, and we were actually up on the roof and looking down and kind of getting a different bird's eye view of the campus. And this is the courtyard area, and I know many schools have areas like this. And even just looking down in this one spot, there are several things that we can point out that we might want to be concerned about from a mosquito control point of view. One is right in the middle of this courtyard. You can see the little drain there. What do you think is inside that? It's storm drains hold water. So even though that might not be something you would focus on when you're thinking about looking for mosquitoes, that's a really important area. We happen to see a container here. This is some kind of a landscape maintenance cart, but I point this out because anything that's plastic or metal that can hold water is potentially a mosquito breeding site, especially after a rain. Other things that might be a little less obvious, up at the roof line. You can't see it, but this roof has a gutter. And anytime you have, especially you have trees hanging over the top of the building, you're going to have debris, leaves, and flower parts and things that fall into the gutters that can provide breeding site there. Also, my eye is drawn toward the vegetation here. Mosquitoes during the day tend to hide out in vegetation, and there could be hundreds or thousands of mosquitoes just in that vegetation during the day. It will come out in the evening or on cloudy days to bite people. So even in a seemingly barren spot like this empty courtyard during the summer, there are plenty of things to be looking at for mosquito control. Just a word about these stormwater catch basins. These boxes, concrete boxes in the soil, are actually designed to hold water. A lot of people don't realize that they just don't drain immediately. They typically have a gap between the bottom of the outflow, stormwater outflow, and the bottom of the container, and that's actually by design to catch storm debris and keep it from clogging up the stormwater drains. But it does pose a huge problem for mosquito breeding, and it would be a good idea on school campuses to map out where you've got these stormwater catch basins and to check them to see what kind of water is sitting in there. And there are, of course, treatments that can be done to get rid of these or to treat these areas. This is just I talk to a lot of homeowners. We even have these type of basins in our backyards, and we typically use them as part of a French drain system. And anything that holds water underground can be a common source of mosquito breeding. In this case, you can, on smaller ones, you can actually fill up the bottoms with pea gravel or something to eliminate that as a breeding site, but you probably won't, the city won't want you to be doing that on the commercial storm drains. It's just so easy to, can't overemphasize how easy it is to overlook breeding sites on a school campus. And this just a couple pictures to show active mosquito breeding sites found in a typical backyard setting, although it could easily be on a school campus as well. The recipe for mosquitoes is basically a little bit of water, a little bit of organic material, and a container that will hold the water for at least 7 to 14 days. So with those kind of conditions, you're likely to have mosquitoes being produced. And it doesn't have to be a large container. You know, a container as small as a Coke can or less can be a breeding site. So this is something that, again, people with an eye, a trained eye, to be able to go through the campuses and be able to look at these things are really important, because the average school principal is probably not going to know to do this. Again, a gutter with full of leaves, and when a rain comes along, if the rain sticks in this gutter for long enough, it will definitely breed mosquitoes. Another view from the roof of that school, the school water feature, which is, guess what, forgotten after a period of time, a year or two, and the enthusiasm for maintaining it goes away, and the fish die, and you've got a great mosquito breeding site there. So lots of places the school campus itself can generate mosquitoes. And if you wanted to design the perfect mosquito breeding habitat outdoors, you would design a tire. It doesn't matter which way a tire is laid, on its edge or on its side, it's going to hold water. And again, outdoor tires that collect leaves and dust and fill with water during a rain are going to breed mosquitoes, guaranteed. Now you might think, well, we don't have that kind of stuff on our campus, but how many of your campuses abut a creek or a waterway or green belt where indeed there could be these types of breeding sources? Now, the Zika-bearing mosquitoes are not strong flyers, but remember, our number one mosquito-borne disease in the U.S. is West Nile virus, and those mosquitoes can travel up to a mile from a breeding site. So if you're within any kind of walking distance of a creek or green belt that might have trash and debris in it, this is going to be potentially a problem for your school campus. And let's not forget that even natural sites like tree holes can be mosquito breeding sites. So any kind of treed area could potentially have the ability to produce these mosquitoes. By the way, if you've got trees on your campus that are holding water, you can eliminate those by filling them with expanding foam and sealing them off. You typically do not want to use concrete or anything that could damage a chainsaw that might eventually be used to cut down a tree or limit the tree's growth. But a soft foam type material can eliminate that type of breeding site forever without the need for any chemicals. Now, in public health, we often refer to something called the SLAP method for mosquito control, and this is part of an IPM or IMM, integrated mosquito management approach to mosquito control. And it includes surveillance, being out there and actually monitoring for mosquitoes, reducing the source, using larvicides to treat breeding sites, and the use of adult mosquito control. This is probably what most people think of when they think of controlling mosquitoes, but certainly it's most effective when it's done within the context of the whole IMM program. And public education, so important. And again, I think Dr. Leko had done a really good job of pointing out a lot of resources for education that we can be using in mosquito control. Just a few words about surveillance. We typically use some specialized traps for surveillance. This is what it's called a B&G Sentinel trap. It's a cool little trap that's got a black top to it. Mosquitoes, especially the Aedes mosquitoes, are drawn to black circles because they look like water holes in a tree or a black container. And it may have an attractant in the bottom, but it's got a small fan that will draw mosquitoes into the trap. And the thermos above the trap is actually filled with dry ice, so that dry ice is dripping down and covering that trap, making it a little more attractive to mosquitoes. The problem with these types of traps is that the equipment is expensive. A little trap like that white trap on the ground there will cost a few $100s. It also requires trained personnel to maintain and interpret the data that you get from the traps. So it's really, for a school district, you're probably not going to be doing surveillance, but knowing that it can be done and tapping into information from a surveillance program, especially from your city or mosquito control district, can be very informative. There's another type of trap I'll just show here because what we use quite a bit with West Nile virus is a gravid trap, and that's actually a bucket of stinky water, polluted water that's produced usually by putting grass clippings or similar material, rabbit pellets or something, in some water, letting it steep for a couple weeks in the sun, and then pouring it out. The stinky water is very attractive to Culex mosquitoes especially, and traps have been designed to suck up mosquitoes that come to those traps, and that's how we typically get our collections of mosquitoes for use in testing for West Nile virus. Again, it's something that's needs to be done by a professional group, and you're not, as a school district, probably going to be involved in doing that, but be aware of the tools that are being used. And this graph just shows some data from a couple of our counties here in Texas, Dallas and Fort Worth and Tarrant counties, and this shows the kind of analysis that's typically done with these data. And this is the result of hundreds of traps over many hundreds of square miles of county property, but it's very useful, and it gives you a picture of what's going on in the area. And if there's any way that you can get this kind of information from your local public health authority, it's great to be on a mailing list for this because it gives you a bird's eye view of what's going on with mosquito-borne diseases in your area. So let's get to the question about insecticides and when insecticides might be appropriate for managing mosquitoes. We use insecticides for larval breeding sites. That they're places that can't necessarily be eliminated. There's nothing really we can do about the water in this ditch here, but we can treat it. And as far as adult mosquito control goes, we can apply mosquito adulticides when disease is determined to be present. And typically this is done by mosquito control authorities, but it can even be done by school personnel if it's important enough to your district and you think you have the ability and resources to be able to do that. And we can treat with adulticides as residual sprays to vegetation. What we mean by residual sprays are insecticides that once they get sprayed on a surface, remain there for extended periods of time, days to weeks. And typically we do that to non-flowering plants. Can anybody guess the reason why? If you say bees, you're absolutely right. We don't want to hurt bees and other beneficial insects. So these are generally applied to just leafy foliage where mosquitoes tend to hang out a lot more probably than flowers anyway. Doorways and building entry points. These are a lot of mosquitoes. Bites, I believe, take place indoors, and these mosquitoes get indoors by first hanging around outside of entryways, and then as people go in and out, get drawn in. So those are great places to apply insecticides to kill adult resting mosquitoes. And then, of course, there are fogging programs that are conducted by the community in some of your neighborhoods and cities. Now, larval breeding site treatments is something that municipalities and public health agencies struggle with because there are so many places that mosquitoes breed. So this is something a school district can do to help reduce the risk of mosquito bites and mosquito nuisance problems. And there's two chemicals that are commonly used for this. The first one is a bacterium called Bacillus thuringiensis. It's actually a toxin that's produced by a bacterium that's placed into either granules or donuts, like you see in this red package here, that slowly dissolve over time, usually about 30 days or so, and kill mosquito larvae in the water. These are very specific to fly larvae, which mosquitoes are, type of fly, and they're very safe for other animals. They won't hurt fish. They won't hurt animals that drink out of the water, the treated water, and so it's probably our number one consumer-used mosquito control product. Methoprene is another insecticide that's also used. It's got a little advantage over BT in that it's slower to break down. It lasts a longer time in the environment. It's typically used in a granular form, so it can be sprinkled in whatever amount you need into a water source that's breeding mosquitoes. Residual treatments are typically done with one of a number of different insecticides that are typically referred to as pyrethroids. This is a professional application. This is done by a certified pesticide applicator. They can be put out, probably most conveniently put out with a backpack mist blower sprayer that you see here, a unit that might cost $600 to $800 or so. They produce a particle size that's larger than what you'll get with these municipal mosquito trucks that put out adulticides for mosquitoes, but much smaller particles than what you would typically get out of a hose sprayer or a power sprayer. This allows the insecticide to penetrate foliage a little better. It's an affordable way to put out mosquito control insecticides. Typically should provide 3 to 4 weeks suppression of mosquitoes. And it can be applied just when needed and just where needed. So it's a very flexible form of mosquito treatment. Disadvantages, it takes trained personnel to put this out. You want to avoid treating flowering plants, again, for beneficial insects. But other than that, this is an option for some school districts in certain situations. The ultra-low volume type applications are what we typically use with municipal mosquito spraying operations. This is, again, a type of treatment that we use when all other measures have failed. When surveillance shows that you've got disease-bearing mosquitoes in an area, you've done your source reduction, you've done your larviciding, you've given it your best shot, and yet mosquitoes are still present, they're biting people, and they may be transmitting disease. This is when we would use the trucks that can cover large areas at a time. Now, the effectiveness of these trucks supposedly is less for Aedes mosquitoes that carry Zika. And the reason for that is Aedes mosquitoes tend to live in foliage, they're low to the ground. They may be protected by buildings and houses and neighborhoods. And in South Miami Beach and the Miami-Dade area, they're relying a lot more on foot applications using things like mist blower sprayers than the trucks. But the trucks are still used as an adjunct to that door-to-door, yard-to-yard type treatment. In Texas, we typically, if we have a positive mosquito pool in an area that shows that West Nile virus is present, trucks will go out and automatically treat a half-mile radius around that positive find, and do that for 3 nights in a row. And that is one accepted method of suppressing mosquitoes during a disease outbreak. Are there any other ways? Can we get around having to spray insecticide across a school or a neighborhood? There are some other options. There are things called lethal ovitraps. These are artificial breeding sites for mosquitoes that we can put out. Typically, they either have some kind of sticky trap inside that actually captures the mosquitoes coming to lay their eggs in the artificial water source, or they have insecticide in there that the mosquito that comes in and lays its eggs will contact and pick up and eventually die from. These have been shown to be able to suppress mosquitoes in certain situations, but I would say we still need a lot more proof of concept in the field And I think there's a lot of need for information about how many of these need to be used. And it's probably going to be expensive and out of reach for most large school districts because these traps are really more for a backyard situation. Also, there are some new insecticides that are sugar-based insecticides based on the concept that adult mosquitoes typically feed on nectar when they first emerge from the water, and they need periodic sources of sugar to feed on, and by spraying insecticides that have sugar in them, they can sit as residuals on plant surfaces. These attract mosquitoes. They feed on the insecticide sprays, and it's essentially a bait for killing mosquitoes. And again, there's some promise to these technologies, but the research is really still ongoing as to whether they're going to be practical on a large scale. The other thing that you may have read about and heard about are the use of genetically engineered mosquitoes. Now, this has not been done, to my knowledge, yet in the U.S., but it is something that has been tested in Brazil and some other places. Right now the FDA is looking at approving releases of genetically modified mosquitoes to combat Zika in Florida. That's an ongoing battle because, of course, there's people that don't like the concept of genetically engineered insects or plants, and there's a lot of concerns amongst people, and some of which are justified to want to make sure this is only done after careful consideration and planning. The concept with this is that mosquitoes can be reared to have a special weakness in their genetic composition. In this case, they typically rear mosquitoes that can't survive without the presence of a certain antibiotic in their food source, their water source. And so out in the field where the antibiotic is not present, these mosquitoes typically die after they hatch from an egg. The mosquitoes that are being reared and released are male mosquitoes, and when these breed with a female, they transfer the gene that has that weakness in it, and any offspring that come from that mating are essentially not going to survive. So in Brazil, where this has been tested, it has shown to be able to produce somewhere between 80 and 95 or so percent reduction in mosquito numbers. But again, this is still a very experimental concept, and there's a lot of debate going on about the environmental safety of this kind of approach. As Dr. Lako said, the final line of protection against mosquitoes, again, is personal protection, and that includes long sleeve shirt and pants, and the choice of and use of, most importantly, a good repellent. And the one thing I'll add to what he said is that there are some great choices. There's really no excuse not to use a repellent. Some people do object to using DEET, I think because it's got a reputation perhaps of smell and an oily feel, and some people say they're sensitive to it. But and DEET is still probably the top repellent for long-term protection against mosquitoes. But there are some excellent alternatives to DEET, including a plant-based repellent called lemon oil of eucalyptus that can be used. And EPA actually has a very useful repellent calculator on their website. And if you type in to Google repellent calculator, you'll find a couple of different places that will tell you a lot of things about these different alternatives and their trade names and that sort of thing. And I'd like to close my section out just with a plug for a site that I've been working on called Mosquito Safari. This is maybe a useful tool for promoting to families within your school. Know that some school classrooms have actually used this as a training tool for teaching them about mosquitoes and where they breed in the backyard. And basically, it's a walkthrough of a backyard that shows you where mosquitoes are breeding and that. And it gives you information about various aspects about the backyard, tells you some stories about birds and bird feeders, and shows you different containers that might collect water, gutters, and those sorts of things. And it's kind of a fun site to learn about mosquitoes and control. So if you have any interest in checking that out, we're in the process of updating that site to make it mobile phone friendly, and that should be out within the next month or so. And I think that's all I had, Marcia.
Okay, thank you, Dr. Merchant, for your great presentation on proactively reducing mosquitoes on school properties and thus preventing the spread of mosquito-borne diseases. Next, Mr. Dan Lisinko will be discussing how some Florida school districts are responding to the increased threat of the Zika virus in Florida. Dan, the mic's all yours.
Good afternoon, everybody. It's a pleasure being here. We kind of got hit when school opened this year, and due to the fact of what the Zika down in South Florida spread out. So we've started with our program in doing the concerns of the virus. Our work orders coming in from schools increased by 500%. So that was quite an impact on us right off the bat. We started out trying to educate the staff, the teachers, custodians, plant managers, and that, and keeping the school cleaned up of standing water, bird baths, all this kind of stuff, butterfly gardens where they got feeders and stuff like this. And it just kind of expanded from there to having issues out in the play fields, the courtyards, the practice fields. Playground equipment would have standing water in the slides and underneath it and stuff like this. And if the caps aren't on the poles, water might be trapped down inside of that. So we had to kind of pick that up. Our responsibility, the way I kind of looked at it when we got into this, is that we're kind of those first responders. We go out and do inspections where the mosquitoes are breeding, their habitats, and if it's something that we can treat, we'll go ahead and treat the area. We're using a lot of different products in doing it. Barrier treatments and water treatments, BTs, and stuff like this. Basically, we're trying to stay next to the building where we're doing this, where teachers are seeing having problems, covered areas in the going into a school, maybe having mosquitoes up on the walls, around the doorways, and sometimes we'll put up barriers on that kind of stuff. Also in our inspections, it's when I do have to call mosquito control, and we do have a very good relationship with Manatee County Mosquito Control District here, is that we can call and tell them pretty much where the issues are. That saves them a lot of time and gives them a better heads up on what they're coming in to find or to treat and look for them. And a lot of times they help us out on a lot of different things. We have my pest control guys go out on doing regular IPM inspections of all of our schools and kitchens and stuff like this. So we've added the service of treating and looking for mosquito problems. And that's gone as far as, like I say, standing water, tires, plants, downslopes, gutters, drain areas, just property, and also we kind of looking at the property around the school, so that if there's a area that needs to be treated, we can let mosquito control know about that. This picture caught us a little bit by surprise at one point. We have issues with mosquitoes. I called mosquito control. They came out and they found the issue up in the gutter. And as you can see, we got a little plant growing up there. I've always been looking down closer to the ground for mosquito larvae and stuff like this than up in the air like that. Once we got it kind of cleaned out, it helped our situation at the school. That was a big one and something we had to we learned a little bit on that one. There have been just a few applications where we've had to go do a little bit of fogging. I prefer not to do it, but if it has to be done, we'll knock them down for adults, mosquitoes, do a little bit quicker. it does back them off. Let's say if I have a area around the football field, we do have a lot of lowlands and shrubbery close to these stadiums and practice fields. So, but again, that's only been a couple of times this year, but we are equipped to do it. We're looking at our downspouts where lawnmowers are run into the drains. We're trying to get these all fixed so that, and if there's water, we're trying to get the water out, to flow away from the building so it's not standing. And this is part of their inspection. This picture here is a playground, and the area on the other side of the fence is actually a dry retention area, which at this point it is wet down there. And the water's been standing for several months now, I'd say. I don't think it's dried out yet since we've been back. And that is a very difficult area because the kids come out there and they're just getting swarmed by mosquitoes. So again, we've gone in and we've used some surface control products on it around the edges there, trying to keep it down. And this the picture is on the left is just some ruts from a tractor and standing water. And again, this is some areas that we treat. The picture on the right is right next to a tennis court. After we cut it down, there's still water standing in there. Again, it's been sitting there for better part of a week or two. And these are where we use a lot of our biologicals like the dunks. We just throw them out there. They last, 20-some days, 30 days out there. And if it does dry up and it fills up, a lot of times the dunks are still active, so we don't have much of a problem. And it keeps our callbacks down. These are some of the collection areas that we were talking about along the fence lines where your the caps have come off, water collects down inside of it. We're trying to keep fence guys go out there and put caps back on, but we'll put some product down in there and make sure until they get fixed and corrected. Tires, we have big truck tires out there for the football players to throw around for their practice. And we've been going out there trying to get water out of them. And my guys aren't into the football end of it. They're not quite as large as some of these football players. So it's been a real challenge. I was visiting my local mosquito control people, and they said drill holes in it. So now we're on a little program and putting about 4 hose, 5 hose around the side of the tires on both sides to see if we can't get the water out. We're actually trying to do at least a 2-inch hole to help drain the water out because most of the time they sit on their sides. And then if they are flipping them over, some of the water kick out. And that's been more of a problem. These pictures are right up next to the schools. And again, it's standing water. These are actually wet retention areas. The only time the water flows out of it is we get a lot of rain and they flow out through the control structures. So the water does stand in there for a considerable amount of time, if almost all year. We come in, we do some surface control for the larvicides, and it kind of helps keep them down. And that lasts for several weeks. We're also watching for plants, bromeliads. We've gone through and removed them from our schools. Not a very popular choice, but again, it reduces the mosquitoes from having a harborage area. And we're also trying to educate and treat the trees where they have holes in it. We have been doing some foaming as best we can and trying to get, we got several cans of aerosol foams to go in there and just foam them up real quick. And also look around the trunks of the trees. We find a lot of areas underneath there that are got some hollow areas, and we find water sitting there, especially when you got a lot of mulch around there. Other natural breeding sites, long-standing puddles, potholes, these can hold water, especially like our rains that we're having right now about every day. It just doesn't really dry out, and it just takes a little bit of water down in there for them to start breeding. And it's surprising how many mosquitoes that you find larva size down inside of them. Another one of our troubled areas was our ag areas. Florida's pretty big on ag, especially in this area. So almost all the schools have an ag department where we got standing water for the cows, the pigs, everything. And the one picture there to the top, we've got we turned those upside down to get them drained out. There's another water trough out there that's kind of covered that seems to help a little bit better, but the mosquitoes can't get into that. Where there's no real way of draining them until they get all the way down. So we're looking at putting some BTs in there to help them out. Again, there's our trash areas. The bottom, if the trash pickup's not on time, again, you're looking at mosquitoes in 7 to 10 days. Some of these trash areas and dumpsters may not get dumped for a couple of weeks in some of the schools. So you get a lot of yucky stuff underneath it and inside of them. And again, we're doing a lot of treating. Garbage cans, we just go around keeping them dumped. Because of the way a lot of our drainage away from our schools, they go into your catch basins, your drainage systems, your storm water, which all hold water. But we also have found an awful lot of French drains, which come off of a roof and a play area, and it goes into the French drain and bubbles up and spreads out into the field. Well, these hardly ever dry up. We're learning a lot in doing this. Again, we're treating these areas also, and hoping that that'll help reduce the mosquitoes. But a lot of these French drains are close to the playgrounds where the kids are playing. So again, the mosquitoes don't have to go very far and catch one of the kids and have a good feed day out on them. We have been trying to let the schools know to use repellents. We're looking at trying to get some kind of a brochure out for the parents to give them an option of different repellents, and so the kids will use them. I do know I believe it's down in Broward or Dade, they are actually giving out repellents, or they're spraying the kids out before they even go outside to play for their recess times and stuff like this. Okay. And again, these are some of the products that we use. The biologicals, the mosquito dunks, I think, are probably one of our best ones we're doing. The BTIs, growth regulators, we're using a lot of it out there. And that seems, we're just going through an awful lot of it. I've just got another order in just to the fact I don't think we've kind of finished a whole district-wide inspection yet for mosquitoes. We're still working on it, and so we're doing an awful lot of treating and see what happens next month to see if our work orders kind of taper off a little bit. And like going back and educating the teachers and getting them to educate the parents and stuff, trying to reduce their fears, let them know that we are doing something, going through district emails, informing the staffs and management efforts as we go out. Every time we go out, we're talking with them to make everybody more responsible for reporting standing water. And if they can't handle it, we'll send a group of guys out there to do it for them. And that's about it. So it's been kind of a challenge this year in this. Again, working with staff at Manatee County Mosquito Control District has been real helpful. They get out there and they'll do our bigger areas for us, and I think hopefully it helps them too. That's pretty much all I've got on it.
Dan, thank you for sharing what some Florida schools are doing to prevent mosquito-borne diseases. Next, I'll cover a few short announcements. We'll begin the Q&A right after the announcements, so please post any other questions you may have for our presenters into the chat box now. Okay, the topic of our October School IPM webinar is keeping bats out of the school buildings. No, we're not trying to deny bats in education, and the timing of the webinar has nothing to do with Halloween. Fall is a prime migration time for bats to fly south, and bats regularly seek harborage roosting locations along their route, stopping in, on, or around schools. Live, fallen, sick, or dead bats are regularly found by students. Bats in your buildings or on school grounds can be both an expensive pest to eliminate and are a potentially serious health hazard via their guano and the threat of rabies. So please join us on October 18th for this intriguing webinar and take note of the remainder of the monthly school IPM webinars listed here that take us through the entire school year. A few hours after the webinar concludes, you'll be sent a link to print your own certificate of attendance. For some of you, these certificates will provide supportive documentation for continuing education credits. The School IPM Listserv is our way to assist and motivate those in the school community to start, grow, and sustain their IPM programs. By subscribing, you will receive invitations to upcoming webinars, highlights from links to IPM-related newsletters, and receive updates on EPA's school IPM activities. If you are not already on our listserv, please go to our website, or you can email us at school.ipm@epa.gov. Thank you again to our great presenters, Commander Joe Lako from the CDC and in Atlanta, and Dr. Michael Merchant from Texas A&M Research and Extension Center, and to Mr. Dan Lisinko from Manatee County School District in Florida, and to each and every one of you, our audience, for participating in this webinar. In a few weeks after the webinar is concluded, a list of all questions and answers related to this webinar will be provided on our website, along with a set of resource links, the PDF of the PowerPoint slides, and in time, the recorded presentation, which will be available for on-demand viewing and will also be located on our School IPM webpage. In a few moments, you will see a short series of questions on your screen. Please help us by answering these short questions. Now, we'll begin to entertain the questions that you posed during the webinar in the question pod. Any questions that are not answered during this session will be answered by our presenters and placed on our website. So, without further ado, the first question is, where can we find the most updated Zika information? Commander Lako, can you answer that one?
Yeah, if you refer back to my slide and go to cdc.gov, you'll see the silhouette of the mosquito, and that'll take you to the Zika virus homepage. That's where we update that regularly at a very minimum of once a week with the arbovirus information, but a lot of the resources are updated 2 and 3 times a week.
Thank you. This one will be for Dan Lisinko. Considering outdoor gym periods and after-school sports, how have some Florida school districts altered their policies on mosquito repellent application, and who applies the repellents?
I know that some of your elementary schools, the teachers have applied it to the children before going out. Our district hasn't really put out any kind of a protocol for it yet. We have emphasized that the football players and stuff like that do it, put some type of repellent on when they're going out. Again, we're just trying to get the parents and the teachers to understand it and maybe start bringing it in and using it.
Okay, let's see. For Commander Lako, I often get mosquito bites through my clothing. Is there a specific type of clothing recommended, or better to make sure to use repellents on both exposed skin and clothing?
Yeah, I think the thinner your clothes, the easier it is going to be for a mosquito to bite through that. I would recommend either pre-treating your clothes with special products like permethrin designed to pre-treat with pesticides and repellents, or just use repellents not only on your skin but as well as on your clothes and even your hair.
This one's for Mike Merchant. Is there any data focused on Zika by gender, race, or age?
That's a good question. I have no idea. I would assume that data is available through CDC. Joe, do you know anything about it?
No, I think that is an interesting question. I don't know that that's ever been examined, if they have a preference for boys versus girls or older people versus younger people.
Okay,
one thing that I might just mention, Marcia, is it's the greatest risk for Zika is women who are pregnant or could become pregnant, and the risk to children is relatively low. Not to say that we want our kids to get Zika, but we are dealing with a disease that is a lot less important for children than it is for young women and their families.
Thank you. Joe, I have another question here. Once you have the virus, how long would you still be contagious?
It's going to vary from person to person based on your own status of health and whether or not you're immunocompromised. But typically it's going to be 7 to 10 days, maybe up to 2 weeks in some individuals.
Thank you. Dr. Merchant, do you have to reapply BT to drains after a heavy rain?
Yeah, you definitely will. That's one of the disadvantages of these larvicides is they don't last a long time, and certainly any kind of rain that's going to dilute the breeding site will wash out the insecticide also. On the other hand, especially for West Nile virus, a good rain to wash out breeding site is exactly what the doctor ordered, because the Culex mosquitoes that transmit West Nile virus like dirty water that's been sitting for a while and becomes stagnant. So rain's a double-edged sword. It helps with the West Nile virus, but it certainly does wash out our treatments that we put in there so painstakingly.
Another question, and this could be for either Joe or Mike. Do you have parent education pamphlets available in English, Spanish, Vietnamese, and Mandarin?
I know on CDC's website and the communication tools on the Zika virus page, there are various forms of media specific for parents, and I do know that they come in English and Spanish. I'm not sure about some of the other languages, though.
Thank you. Mike, how long does the Alticid last?
Alticid's supposed to have about a 30-day lifespan, and it's actually comparable to some of the better BT formulations that have a slow release. BT does not last as long as Alticid, but if it's in a good slow release formulation, it can extend for 30 days as well.
Okay, another question, I think for Joe here. Is there any repellent that can safely be used on children 6 months of age until they're 2?
I would strongly look at the label on all repellents and go by the manufacturer's recommendations. It will have been vetted by the EPA with their human health safety standards. I wouldn't recommend any repellent use for children 2 months of age and under. For the others, I would use the recommendations by the manufacturer. That's going to probably be varied based on the strength and concentration of the active ingredient.
Okay. For Dan, who is recommended to do the inspection on and around school property? Is it the custodian?
We try to get them, we're trying to train them so they can help us, but I do the training for my pest control department, and they go out and do a lot of these, almost all the inspections right now. But it's such a big task that we're trying to get more help from the schools. We have about 60 facilities out there, so it's pretty hard for us to go through and do a complete inspection within a reasonable time. But we are, I do the training, and then my guys will go out and they'll help train the custodians and plant managers.
Okay, Mike, if Aedes species are low flyers, is a high roof gutter, second or third story height, a place that females may still lay their eggs?
I wouldn't put it past an Aedes mosquito to be able to go up that high. There's probably a little less chance for them to be up that high. It might be more likely to be a Culex breeding. And they can breed in the same sites. You can get Aedes and Culex in similar breeding sites, but I wouldn't assume that it's safe just because it's up a couple stories. A wind can blow a mosquito up to a higher area, so I would still be paying attention to rooftops.
Okay, Dan, a little more clarification on the repellents. Are the school systems allowing students to bring repellents to school or after-school activities, or are the schools supplying them?
No, the schools aren't supplying them. It's right now the students are bringing their own in our district. In other districts, I believe the school is supplying them.
Okay. For Mike, how much of the larvicide is required for an average storm drain?
That's going to depend, again, on the label. The label for each product is going to be slightly different, and the label will tell you as to, usually it's based on square foot of the water surface being treated. So I don't have an answer for that. It's just going to be label-based.
Okay. For Joe, I have heard using dryer sheets to wipe your skin and put it on your pants pocket helps to decrease mosquito bites. We did this when we went to Honduras on mission trip, and it seems to work. Do you have any comment on that?
No. Officially, CDC would recommend EPA-registered products for use as repellents. That's going to be based on scientific data and information as well as peer-reviewed studies.
Thank you. One more question, and this one's for me. Could you provide a link to the recording for this webinar for reference? We will be sending out the information with the link, and when everything is ready and put up on the website. And in addition to that, we will also, it will take a couple of weeks for this to happen. So, you just have to be patient, but we will get back to everyone, not just the people who are on the call, but also those who registered. Thank you, and this concludes our webinar on protecting students from mosquitoes and the Zika virus at schools. Thank you so much for attending. We hope you tune in again next month for the next school IPM webinar. Remember, don't give mosquitoes a biting chance. Thank you.